Hello everybody, welcome back to my YouTube channel NSR Info Technologies. In today's session, I'll be discussing with you how to handle error records. Okay, error handling in our Azure DataBricks using PySpark as the language. Alright, so here the moment you're trying to read any CSV file, you might be encountering different kinds of error records. Okay, so if you see here, this is one of the sample table wherein you are having different kinds of if you see here, this 103N, this is a corrupt record. Okay, that means it is not a valid record, it is a bad record. Not only this, you have another record in this particular file which is 4K under this employee salary, which is also a corrupt record. Okay, so basically there are two corrupt records in this particular file and we need to handle these errors. Alright, so how do we handle those errors? In our Databricks, we are having different kinds of methods wherein we can handle it. So what are the different kinds of modes we can handle these bad records or corrupt records? You have three different kinds of options when you're trying to read the file. So the different modes are permissive mode, drop malformed mode, and fail fast mode. Alright, so these three are the different kinds of modes wherein we can use them and we can handle the bad records or corrupt records. This is one of the option we have, which is nothing but mode, and the other one is bad records path. Okay, these are the two different options which we are having. Alright, so now let us quickly go to the percentile FSLS. So this is nothing but let us list down what all files are present in my Databricks file system, which is my local DBFS file system. Okay, let me execute it, and before that I am having my sample underscore S1 cluster which is up and running. So make sure before executing your scenario you need to have your cluster up and running. So since it is the first time I'm executing, it will take a little time. Okay, now it got executed. So let us see what all different files we have in our Databricks file system. These are the different files which are placed in my file store under tables category. Okay, so now let us see. My intention, this particular file is there, right? This is the file. This is nothing but error handling.csv file which is present inside my file store tables. Okay, this one, if you see, this is the name of the file, and this 129 is nothing but size, and this is the last modification date. Okay, alright, so now let us, how do you read any particular CSV file in PySpark using spark.read.csv? We will be loading that particular path, and since it is a CSV file, we will be obviously having the first row as header, right? So that is why we'll be putting this option, header is equal to true option, and then we'll be assigning it to a data frame and we'll try to display it. So this is how we will be normally reading any Spark file, PySpark related file, be it a CSV file or a JSON file, XML file, whatever. Okay, so if it is a CSV file, we will be giving it as .csv and we will be loading that particular file path. Alright, so now the moment, okay, so first let me just try to execute each and every command here. So initially let me see what all we have inside this file store. Okay, so you have something called as tables, and in that your tables is one of the folder which is available, and after that inside the tables what all we have, this is the information which we are having. Okay, that means we are having 7 different kinds of records, we are having different kinds of files we are having with different size and its modification date. Alright, so after that let me try to just execute this one, which is nothing but I'm trying to directly see what all information I'm having inside error handling.csv file. So here the name is error handling.csv file, its size is this much and its modification time is this much. Alright, so now I have this particular file placed in this particular folder. Now I can directly load that particular file, read that particular file. So how do I read it? Using spark.read.csv, load that particular file path, header is equal to true, as it is a CSV file. Obviously the first row will be header, so that is why I'm using this header is equal to true option. All right, so after that, let me quickly display it. The moment you display it, what will happen? Whatever information is present in that table, okay, in that particular file, the entire table, here data frame. What is a data frame, by the way? Data frame is nothing but you can organize the data into named columns, right? That means within the columns the data will be organized. So if you, the moment you give display of data frame, so this is the information which will be present, okay. Different columns, that file is having different columns: employee ID, name, salary and department. And here, right, I'm having 5 different records. All right. Okay, so after that, what I want to do, I will just try to give a print schema. Okay, that means I just want to see what schema it is referring to. So the moment I display this one, the moment I execute this one, right, you can see what all schema, like what is a particular column name, and along with it what is the data type name which is available. That thing you can actually see here. If you see here, employee ID is a column which is holding integer related values, but here if you see, I'm having string related values, okay, which why did I get it as string? That is because here I'm having a column, I'm having a record which is having this n, okay. So that is why by default, as we have not specified any info schema, what happens by default, it is considering every data type column as a string, okay. And then employee name will obviously be a string, salary it is also considering it as a string, whereas department it is obviously another string. All right, so this is not the schema which I want, okay. This is not the schema which I want. I want this employee ID column to be integer and employee salary column also to be integer. So in order to customize the schema, we need to define the schema. So how do you define the schema? So for that, we have an approach. So this is the way to actually create the schema, right? If you want to manually define the schema, what is the procedure? This is the procedure. So here if you see, I have I have this struct type. This is one of the method which is available in our PySpark SQL. So we, in order to use that, right, before using it, we need to import it, okay. Before using it, we need to import it. All right, so this right, I have already explained you in the previous sessions, like how to create data frames using multiple options. So one option is directly using the data frame, how to read it, and the second option is how to customize the schema, like based on the particular different kinds of data type values. If you want to explicitly specify, okay, for a particular column, if you want to explicitly specify its data type, then you can make use of this struct type. This is a second methodology, and using this you can actually create the data, create that particular data frame, okay. All right, so here, right, what am I using? I'm using a struct type, whose inside that I'm passing a method called as struct field, wherein I'm, for each and every field, I'm naming one of the column and I'm assigning some data type to it. So if you see here my employee ID is a column which is holding string related value, but I don't want that to be string. Why? Because it is holding integer related values, okay. So since it is holding integer related values, I'm giving the data type as integer. Similarly with the employee salary, this is also holding string, which I don't want it to be string. So that is why explicitly using this methodology, I'm passing integer as the data type, okay. So along with that, if you see, these are the 4 columns which are present in the earlier CSV file, but here using this customizing, using this particular struct type, what am I doing? I'm explicitly creating one more field, okay. What is the field? Character record is one of the field, and for that particular field, I'm passing the data type as string type, okay. I'm passing the data type as string type. All right, so now let us see the next one. So let me just execute this one first, and then the next one. So now what am I doing? I am explicitly trying to create a structure, okay. For the CSV file which I'm already having, I am having 4 different records in that, 4 different columns in that. So for that file, I'm adding a new column called as a character record, okay. Character record. That character record, I'm passing it as a string type, okay. All right, so I have told you, right, like if there are any particular bad records, okay. So if you just see here, I will highlight this one. So So if you see here, this is one of the record which is a bad record, and this is also a record which is not a good record. Okay, these two are the records which are actually holding different values. So actually this particular employee ID is the column which will be expecting integer related values. But if you see here, I'm getting n, like I'm getting some other number, sorry, some other character which is not valid. So that means it is a bad record or a corrupt record. So this one needs to be handled, and the other one is under employee salary. I'm having something called as a 4K, which is not expected actually. Okay, we are expecting integer related values, but it is holding 4K, which is not an integer related value. Okay, so I want to handle these two particular values. So how can I handle it? For that we have three different kinds of modes, as I've told you, right? So the first mode is permissive mode. So what is this permissive mode and how to make use of this permissive mode? So basically, the moment you are reading a particular CSV file, you will be choosing this permissive mode. So in this particular file, right, there are few values. Okay, there are few values which are not correct. Okay, so as per the schema, these values are not correct. So if you don't actually use the particular mode when you are using it, what will happen when you're trying to execute your PySpark scenario? When you're not using an appropriate mode, what will happen? These records will be corrupt records. Okay, these records will not be handled properly. So in order to handle those records properly, what we need to do? We need to make use of the appropriate mode. For that, one of the mode which we have is called as a permissive mode. So using this mode, what will happen? It will, whatever are the bad records are there. Okay, in our example, these two are the bad records. So whatever are the bad records are there, right, those bad records will be ignored. Alright, so those bad records will be replaced with null values. So instead of this 103n, null will be stored. Instead of this 4K, null will be stored. Okay, not only that, remember, not only that, along with that, a new column will be added. Okay, what is the column name? We have just specified here, right, corrupt record. So a new column will be added for this particular CSV file. A new column called as corrupt record will be added. And in that particular column, what will be the records? If you can consider, what will be the values? So wherever there are different kinds of wherever there are any junk records or bad records, right, so the entire record will be captured. Suppose this 103n, so this is a field which is actually corrupt record, right? So what will happen? A corrupt record column will be added, and in that particular column, what will the value be, corresponding value be? It will be like 103n EMPC 5000 prod. So that will be the value which will be stored in that corrupt records value. Okay, in that particular column, that will be the value. Similarly, here also you will be able to see the same. So 1002 EMPB 4K test. This will be the value under this particular corrupt record. Along with that, what will happen? These values will be replaced with null values. Okay, null values will be replaced. So let us just execute it and see. So if you see here, this is one of the mode which we are using. Which is the mode? The mode is permissive mode. So using this permissive mode, what are you actually trying to do? You are trying to read a file. Okay, spark.read. Option is a permissive mode. Whereas the CSV file, what is the CSV file? This is the CSV file. Since it is a CSV file, first row will be header, and then you are giving this schema is equal to my schema. Again, what is this my schema? If you just go here, right, my schema is nothing but it will consider this particular schema. Okay, all right. So now your CSV file will not be holding four columns, but it will be holding 5 columns. And what will the fifth column be? This will be the fifth column. Okay, all right. So let me execute this one and show you the difference. Okay, it got executed. Now if you see, I have told you, right, like this is your main file. Okay, this is your main file, and if you see the corresponding record as 1002, so I have told you this particular 4K value will be replaced with null value, and along with that you will be having a corrupt record column whose value will be the entire records values will be it will be captured here. Okay, similarly for the 103n EMPC. So if you see here, this also has been replaced with a null value, and along with that the entire values have been captured. Okay, the entire column values have been captured. So this is how you can handle a bad record using this first mode, which is a permissive mode. Alright, so after that we have another mode called as drop malformed mode. So this, using this permissive mode, what can be achieved? Like if you want to handle if you want to handle, like, replace the value bad records with the null values and add a new column called as a corrupt record, at that point of time you can actually use this scenario. Or else, if you don't want to capture it like this, okay, if you don't want to capture it explicitly, what you can do, you have another option called as drop malformed. Okay, that is one of the mode which is available. So using that, what will happen, wherever there is a junk record, okay, so wherever there is a junk record, using this mode, drop malformed mode, you can drop the entire record. So that means from this file you are having 5 records. Using the drop malformed mode, what will happen, these 2 records will be dropped. Alright, only this 1002 record will be dropped, and this particular record also will be dropped. So let us execute that and see. So simple, when you are trying to read the file mode, here itself previously you have used permissive mode, so now you will be using drop malformed mode. That's it, everything will be the same. Okay, if you see here, mode will be drop malformed. When do you use it, by the way? Suppose there are any junk records in your particular file, and if you don't want those junk records to be loaded, if you don't want those to be loaded as null values or any specific column, if you don't want to add it, then what you can do, you can just go ahead and use this drop malformed wala mode. Okay, so the moment you use it, what will happen, only the good records will be present. What if even in a particular record, if there is any single value which is a junk, the entire record will be dropped. Okay, so let me execute this one. Okay, seems like the execution is done. Alright, so now if you see here, what are you getting? See the entire, I have told you, right? So here you are actually having 2 different records which are bad records. So since you are using drop malformed, what is happening? The entire record has been dropped. Okay, the entire record has been dropped. So that is what you will be getting when you are using drop malformed. So what is the last mode? We have another mode called as a fail fast mode. So when do you use this fail fast mode? Suppose there are few errors, okay, there are few junk records in your file, and you don't want the entire record to be deleted, or else you don't want the values to be replaced with null values, but you want your execution, but you want some error to be thrown, some exception to be thrown. So using this fail fast mode, what will happen, whenever any error encounters, right, automatically your PySpark will stop the execution. How will it stop the execution? By raising an exception. Okay, so let us see how to use that. So this is very simple. Okay, the mode will be fail fast mode again, and these are the basic like we have seen previously only. So let me execute it and show you the error. Here one exception will be raised. That exception will be related to the mode, like it will also tell us, if you see here, malformed records are detected in the, when we are trying to parse the file, right, there are few malformed records which are detected. Okay, so what is it suggesting? It is suggesting us to use permissive mode. Okay, and along with that, what is the error which it is telling? It is telling bad record exception. Okay, that means here in your file you are having some record which is having something called as a 4K, okay, which is supposed to be an integer, but it is a string, which is supposed to be an integer, because if you see here, the schema which we have defined, it is nothing but an integer. Okay, so that is why it is showing us number format exception, that is, it is expecting a number, integer value, but you are sending string value. 4K is nothing but a string. Okay, so that is why this exception has raised. So even the input also it is telling what is the value where we are getting the bad record, also it is telling, which is nothing but 4K. Okay, so this is the bad record which we are getting. So that is why, so using this mode, what will happen, you can abruptly stop the execution of your particular file. When you're trying to read a file, you can stop the execution abruptly. So if you don't want to stop the execution, you can also use try catch block. So in your Java programming language, we used to have this try catch block, right? So similarly, like using that try catch block, what we can do, suppose if there is any on the event of any error, okay, if any error has happened, then what we can do, we have the option to raise an exception. Okay, you can handle the exception on your own by using this try catch block, right? So similarly, in our PySpark, we have try and except. So this is the one we are having. So it's just very simple. Wherever you feel like there might be an exception, whenever you're trying to read a file, you might feel like there might be an exception, it might abruptly stop your execution. Then what you can do, that kind of query, that kind of event, you can just put it inside the try block. Okay, inside the try block, if you feel like there is any statement which could cause an error, so that particular statement could be placed inside the try block. After that, if you want to handle that exception, okay, like if you want to have some kind of output with some user defined message or with some any kind of message, so then whatever message you want, you can put that message inside the exception. Okay, so inside the except block, you can put that particular error message. So in this way you can actually handle it. Okay, so the moment you can execute it, what will happen, let us see. Okay, so what is the output it is telling? You can actually handle it without having to abruptly stop your execution of your notebook, right? What you can do, you can explicitly specify some message. Okay, this is nothing but the exception which is handled in a proper way. So using try and except block, you can actually handle if you feel like there are any statements which could cause errors. So those particular statements could be placed inside the try block, and whatever error message you want to handle, so exceptions if you want to handle, so that particular error handling could be done inside the except block. So here I just want to specify some hard coded value. Okay, while reading the file, there are few bad records and hence the exception is raised. So the moment you execute it, obviously in your source file you're having two records, okay, two values which are not actually correct values, which are corrupt values. So that is why you want to raise an exception, and with what message you want to tell the user that there is an exception happened, with this message. Okay, so that message would be hard coded and it would be sent inside my print statement. Alright, so this is how you can actually handle your bad records, corrupt records, using modes which are permissive mode, drop malformed mode and fail fast mode. So along with that, you have another option also called as bad records path. Okay, so if you want to use any of this method, you can very well go ahead and use it, or else if you don't want to drop any kind of records, or if you don't want to load the null values, like replace the null values, or if you just want to redirect those to a completely different kind of file. Okay, if you don't want to drop it, or else if you don't want to replace it with null values, or if you don't want to raise an exception, so what you can do, you have another method. Okay, the another method is called as bad records path. So using this method, what you can do, using this method, right, we can actually log our exception, whatever errors are there, right, we can log those errors in a completely different folder, like in whichever path you want, you can just specify those and you can just put them in a particular folder. Okay, so that is nothing but your bad records path. So let us see how to use that. So it is very simple. Here also we will be creating, like we will be reading that particular spark.read option. So here I will be specifying some bad records path. So this is the path where I want to log it. Okay, so let us just name it with something else. Okay, bad records log, some name I have specified. So what will happen, the moment I run it, the moment I execute it, what will happen, if there are any kind of errors, right, so the error would be logged under this particular folder. Okay, let me execute it. Alright, the execution is done. Now let us go and see if the error has been captured under this particular folder or not. So let us list down this one, execute it and see if the file has been created or not. Okay, there is one path whose timestamp is this one. Let me just execute that. Okay, let me do one thing. I will copy this entire path. and execute it. Okay, so now it is telling that okay, I have a file under bad records log under this timestamp. So what did it do? It has created another another folder called as bad records folder, and inside that folder you are having some information. Okay, inside that folder you are having the record which was logged. So let us just see that. Execute it. Okay, so now if you see here, this is the name of the file, part file. Okay, part file whose size is 304 and its modification. That means just now a file has been created under this particular folder. Okay, so this was the folder which we have given, right? Bad record logs folder. So inside that, with the timestamp, there was another folder which was created called as bad records folder. Inside that you are having a part file. Okay, part file whose size is some 300 MB. Sorry, 300 kilobytes. Alright, so now I want to read this particular file. How do I let me just copy this one here till here, and then let me copy this, paste it here, and see what information I'm actually having. So the intention using this particular this particular methodology, like bad records path, what is the intention using this bad records path? Like if you want to redirect the logs, okay, error logs into a particular into a separate folder. Okay, so if you want it to be stored somewhere else in another folder, then you can make use of this particular option. Okay, so what am I doing? I'm using an action called as take of 10, which will give us the information, what all information is present in that file, right? We can just see that. So till 10 records we can see what all information is present. So using this sc.txt file, we can just execute it. So let me execute it. Okay, invalid input exception it is telling. All right, so let me copy it properly. So this is the file. Okay, execute it now. Alright, so previously there was some error with when I'm copy pasting it, not an issue. So now I have chosen the exact path which is specified in the file. So here if you see, I'm trying to display the 10 records, right? I'm only trying to display the 10 records. So if you see here, what is the exception it is throwing, what is the error which was logged in this folder, bad records folder? There is something called as a number format exception for input 4K. Okay, so in your input file there is a value whose value is 4K. So that for that particular column, this number format exception has been raised. Not only that, there is also another record which has failed, due to which exception, number format exception again. So for input string, what is the value? 103n. So for these two particular inputs, this particular error has happened. What is the exception? Number format exception. So what we can do is, after capturing this bad records path, right, you can just contact your business. You can update the particular file, whatever file you have received just now, right, this information, log information. You can just specify the same to the business. They will correct it, they'll rectify it, and give it back to you, so that you can again upload the file and execute it. Okay, so this is how error handling would be done in our Azure Databricks using PySpark as the language. So using 3 different modes, if you want, you can use it, or else if you want to record the corrupt records using this path, like bad records path, you can also do it. Okay, that's all. I just hope this particular session is clear for you. If you have any doubts, feel free to reach out to me. You can always post your queries in the comment section. Okay, so until then, have a good day guys. Bye. Stay tuned for more videos. I'll be posting them very soon. Thank you. Please do subscribe to my channel if you have not already done it. Thank you guys. Have a good day. Bye.